Unit 5, Lesson 3. The title is The Shape of Data. So, to represent the data, we need a graph. Some graphs are more suitable than others for displaying certain data. So, we're going to study the 4 different graphs that we have, and we'll see when we can use each graph. So, for the first one, circle graph. When we can use it, this is to display data that are part of one whole. This one whole is very important. It's keyword. Why? Because we will see now an example to show how data can represent or are parts of one whole. So let's see an example of circle graph. If you look to this one, this to represent shoes in family closet. So the sandals 30%, the dress shoes 20%, running shoes 15%, and slippers 35%. They are all under the category of the shoes of a family. So it's like to represent one whole. They are not different. They are not different family. They are not shoes and other dress. No, it's only for shoes in one family closet that they represent one whole. And as you can see, the percentage 30%, 20%, 15%, and 35%. If we add all together, it should be 100% at the end. So I'm gonna take the 30, the 20, it's 50. Now we add 35, that means 85, and after that we add the 15, it's gonna give me at the end 100%. And this is in percentage, or we can say 1 if we take decimal, because this one is going to be 0.3, this one is going to be 0.2, this one is going to be 0.15, and this one is going to be 0.35 if we switch it to decimal. How we are doing that? We divide by 100. So if I'm adding 0.3 to 0.2, it's 0.5. And if I add 0.35 and 0.15, it's going to give me another 0.5, 0.5 and 0.5 is going to give me 1. That's why we are saying one whole. So this is the first type of graph. Second type, it's line graph. Display data that change over time. So when you are going from one day to another or 1 month to another, there is a change in the data. So let's see an example to show you what the difference between the circle and the line graph. So if I look to this shape, it's this data represent the height of snow during a week in March. So if you see on the horizontal axis, there is days of the week. So you can see Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And in the other vertical axis, you will see the height in centimeter for the snow. So here it's 5, 10, 15, 20, till 40 centimeter. So we are saying from the beginning that line graph display data that change over time. So let's see the change. Sunday, it was 10 centimeter. Monday, it changed and it started to be 25 centimeter. Tuesday, it went down a little bit, 20 centimeter. Wednesday, it became more to 40 centimeter. Then Thursday became 30. Then Friday, not too much snow, it was 10 centimeter. And Saturday again to 25 centimeter. So this is to show you how the height of snow it changed over the time from one day to another one. That's why we use, or we prefer to use, the line graph. So we saw the circular graph, we use it when we have a data that are part of one whole. The line graph, we use it to display the data that change over time. Now there is bar graphs. The bar graph display data that can be counted. So we can have amount. We can count it in centimeter, in kilometer, in kilograms, whatever we have, but it's counted. And there is a small note here, it's saying when there are 2 sets of data, a double bar graph is used. When we are using this one, it's for average rainfall for Plymouth. So if you see the x-axis, it's January, February, March, April. So this is per month for the 12 months per year. And we see the quantity of our average the rainfall in millimeter. So in January it was approximately 146 millimeter. After that in February it went to 110 millimeter, and after that in March it went to 83 millimeter, and so on. So we can gather or we can count the data. It's counted. That's why we are saying display data that can be counted. In this case we use a bar graph, and as I said, if there is two sets of data we need to use double bar graph. The last type of graph is a scatter plot. The scatter plot displays two related sets of data that are measured or counted. That means you are not gonna find in one axis names and the other axis numbers. No, you're gonna see numbers in both axes, the x and the y. So let's see a good example of a scatter graph. As you can see, scatter graph showing shoe size depending on the height. So let's say someone he has a height of 176, he will have a shoe size 9. This is some example. Let's see another one who has a height of 178, he has a different shoe size, and so on. So you see here there is a number to be counted, and the other one again a number to be counted. So there is two axes with numbers, not one with name and the other with numbers, or the vice versa. No, as you can see, it both with numbers. In this case we prefer to use a scatter plot to display the two related set of data that are measured or counted. Now I want to get your attention for something very important. We are saying sometimes a graph can misrepresent data because of the way it's drawn. Misrepresent, very danger. If we look to this two graph, right away we say they are different, but unfortunately they are the same. If you look carefully, you will find that this is the interest rate in the left side, and in the horizontal, on the horizontal axis is the year 2008, 2009, 2010, 2011, and 2012, and it shows you the interest rate. Let's see the left side and the right side. Really, both of them are the same, but we see there is a difference, and I will tell you why. These two graphs display the same data. If you want to check if it's the same, let's see. In 2008, the interest rate, it was 3.141, because this is 142, 140, so in the middle, 3.141. Here, because it's very small, we cannot see it, but it's close to 3.14. The second one in 2009, it's 3.142. Again, this is, as you can see, there is no big difference, so 142. In 2010, it jumped a little bit, 3.144. So a little bit up to 3.144. So what is the difference? The difference that the left graph gives the impression that the interest rate is increasing dramatically. If you see here, we're gonna see, wow, the interest rate is amazing. I can put my money in this bank because the interest rate is increasing dramatically. Unfortunately, it's not. Why? They misrepresent you because they didn't start from zero. If you look to the left side, they start from 3.140, and this is how to misrepresent the reader. It should be zero. Then if you look, the right graph is more accurate because the vertical scale begins at zero. So as you can see, they are all close to each other. I can see that there is no big difference, and they are staying in the range of 3.14 to 3.152, let's say. It's not a big jump, but here it shows you that there is a big jump. Why? Because they start from 3.14, 3.142, 3.144. The scale is very small and they didn't start from zero. That's why they show you that the interest rate change or increasing dramatically. But in reality, there is a very small change that you cannot see it even if you start from zero. That's why we need to be careful when we are reading or analyzing any graph, if it's misleading the reader, yes or no. So we have to note that the scale has to start from zero and going up with a nice scale, not with a very small scale like that to misrepresent the readers. I hope you understood this lesson, and see you in the next lesson 4. Thank you.